Alright guys, so we're back with part 3 of our object-oriented programming with JavaScript series, and we're going to talk about association, aggregation, and composition in this episode. So, in real life, entities have relationships with other entities. Basically, objects have relationships with other objects. So for example, going back to our computer object that we were working with, a computer doesn't just have basic properties like a color, height, width, depth. A computer can also have other objects, right? A computer has a processor, memory, GPU, CPU fan, a bunch of other objects that we can think about. We can even go even further. We can talk about human beings. We can talk about, let's say, for example, we have a brother object, right? A brother can have a sister object. Those objects are obviously different, but they do compose of each other. A brother has a sister, and a sister has a brother. Likewise, a person object may have a job object, and a job object can have various amount of tasks. Okay, and I want you guys to start thinking of every single thing that we're referring to in real life. We are thinking of them in terms of objects in programming. So when we have these types of relationships between objects, this is known as association. And association is just when we have objects that have a relationship with other objects, right? We have objects composed of other objects. And the type of relationship that these objects have is a has a relationship. Notice how the entire time I've been saying a brother has a sister has a brother. A person has a job, and a job has tasks. Okay, these are a has a relationship. Just like we said, computer has a processor, memory, CPU cooler, GPU, case, SSD, HDD, all these types of objects. Dog has an owner. A car has an engine. Okay, now there are two types of association. There's aggregation and composition. Now, both of these terms relate to the concept of having objects composed of other objects. They follow the has a relationship, but there is a difference between these two, and we're going to talk a little bit more in the next couple of slides. But let's talk about the 4 types of relationships in association. Okay, because remember, when we were talking about association, we were saying there's a relationship between one object to another object, and that relationship can either be a one-to-one relationship, a one-to-many relationship, it can be a many-to-many relationship, or a many-to-one relationship. So let's say we have a student object and we have a class object, right? A student can technically have many classes that they're enrolled in. If you go to university, you can enroll in max 5 to 6 classes, okay? And a class itself, an individual class, may have many students enrolled in it. This is a perfect example of a one-to-many relationship in favor of a student to the class. So the student itself is the individual that has many relationships to the class. The student can have many different relationships to a class. The student can be taking algebra, they can be taking physics, they can be taking chemistry, social studies, English, phys ed, all these classes. Okay, and likewise, the class itself can have many different students enrolled in it. Okay, so some might say, well, this could technically be a many-to-many relationship, but keep in mind, it just really depends on the perception. In this context, we're saying students have many classes and classes have many students, but we're really talking about just one individual student itself. Let's assume that we're talking about a primary doctor, and let's just say we have a patient and each patient has only one primary doctor. So the patient itself has one primary doctor, but the primary doctor has many patients. So that itself is a one-to-many relationship and a many-to-one relationship backwards. And if you want to think of an example of a one-to-one relationship, you can go ahead and say, hey, look, your social security number, your passport, your driver's license, these are entities that are given to just one person. And that particular person can only have one valid entity of that. Every person has only one social security number. Every person only has one valid passport, driver's license, etc. In real life practice, depending on how you implement these relationships, that is what the main deal is. Okay, but thinking about these relationships, these associations is really important, and it helps you with your software implementation. Okay, so I want you guys to start thinking of objects and thinking of the types of relationships that they can have, and take these as basic examples and extend on top of it. So like I said, there are 2 types of association. There's aggregation and there's also composition. We're going to talk about aggregation first. Aggregation is where you have 2 objects that can live independent from each other. So in other words, the main parent object that has another object, those 2 objects, if they were separated, they can still exist whether or not they are together or they're not together. So let's just say if we were to separate an animal object from their owner object, right? Because an animal has an owner and an owner has an animal, right? The animal being like, let's say a pet, like a dog, cat, whatever. If we were to separate them from each other, could both of those objects live independently? right? And that really just depends on implementation. Some might say, well, technically the dog could go out and find some food. The owner could still live on, even though the owner might be depressed or whatever, that they lost their dog. But in the concept of, developing your software, in an actual implementation, you might have it so that if the animal and the owner object were to disassociate from each other, then you would just destroy both objects because they can't live independently from each other. The animal must have the owner, and the owner must have the animal. Okay, but in an implementation where you can have both of these entities that can live independent from each other, then you can say, hey, look, we have aggregation, because these two objects, despite them being separated from one another, they both can live without each other. Okay, so I want you guys to start thinking of a bunch of different types of objects, think about their relationships, and ask yourself, could both of these objects live independent, or do they depend on each other? And aggregation, like I said earlier, represents a has a relationship between two objects. Okay, an animal object has an owner, and we can also say an owner has an object, and this could be a one-to-one relationship, right? If the owner only has one dog and the dog only has one owner, okay, because technically a dog or any pet doesn't really have multiple owners; it just has one. Okay, but the owner itself, we can say, hey, look, the owner can have many different pets. Okay, so that would be a one-to-many relationship. So composition is another form of association. And again, it follows the concept of having objects composed of other objects. However, it's in the sense where objects depend on each other, right? The parent objects, child objects cannot live independently from the parent. So let's just say, for example, if we were to take our computer class, and let's just say every single object that the computer has, it depends on the computer, the main object itself. So if we were to get rid of the computer class, the motherboard, the power supply, CPU, GPU, those objects would not be able to live independently. They would not be able to exist without that computer object. Okay, the computer object has ownership of these other objects. So that's composition right there. So it's not really super crazy. There are differences between composition and aggregation, and being able to identify these association types is very crucial. Okay, so let's actually look at some examples of association. And what we're going to do is we're going to extend our code that we've used for the computer and animal example, and we're going to go ahead and create multiple objects, and then we're going to aggregate those objects to our parent objects. So I'm going to go ahead and create a class called CPU, or I'm going to call it computer processor. Okay, and this class itself is its individual class. Okay, so we're going to go ahead and reference the constructor. Now the constructor, in case you missed it, the constructor is the method that is invoked whenever you create an instance of a class. Okay, so we're going to pass in arguments into our constructor. So typically we want to pass in fields that correlate to our class. In this case, we have a computer processor class. So let's give it, certain properties such as a brand, because it can either be Intel or AMD. Let's give it the model. So it can either be an i7, i9, i5, i3, a Pentium, or a Ryzen 3900X. Let's give it a clock rate. Let's give it number of threads, so threads. So let's go ahead and give our computer processor a brand. So we're going to go ahead and assign it whatever we pass in. So this dot brand equals brand. Remember, this refers to the computer processor class, and we are declaring an instance field for our computer processor class, and we're assigning it whatever value we pass in for brand. Likewise, we're going to do the same thing for model. Okay, so I'm going to go ahead and create an instance of this class. Okay, so now obviously if we were to log this to the console, we would just get the object. So I'm going to open up my terminal, and you can see we have a computer processor object. And now what we're going to do is we're going to aggregate this CPU object. We're going to go ahead and inside the constructor of our computer class for CPU, this is actually going to not be a string, because in the previous example we actually passed in a string, but this time it's actually going to be an instance of computer processor. So let's actually create an instance of the computer class. So let's do computer. Okay, and we're going to go ahead and pass in CPU, and this is going to be passed in for CPU over here. We're going to pass in a color. The height we'll leave it at 15, width 10, and then depth 15. And clock rate we set to 0 for now. Actually, clock rate is part of the computer processor class, so we're going to get rid of clock rate. Okay, and now if I log computer to the console, we can see that the computer class now has the CPU property, not as a string, but as a computer processor instance. Okay, and like our other objects, we can reference that object, so we can reference CPU. Okay, so that itself is a computer processor instance, and we can reference the fields on CPU. So we can reference the brand. Okay, let me actually use some template syntax, or let me use a template string. So we can go ahead and print out the brand. We can go ahead and print out the model. Okay, we'll leave it like that for now. And we can run the class, and we can run the file, and we can see Intel i9 9900K. And likewise with classes, and we can also have methods on our computer processor class too that can be invoked directly from the computer.cpu instance. So for example, if I wanted to increment the clock rate, I can just do something like increment clock rate, or I can create an overclock method, and then we can just increment clock rate by 0.1, for example. And then every single time we would reference computer.cpu.overclock, it would invoke this method over here. Okay, it's that simple. And this itself is an example of association, because the computer has a CPU. Now, what type of association is this? Okay, well, first of all, let's talk about the relationship. The computer itself has one processor, and the processor has one computer. So this is a one-to-one relationship. The computer doesn't have multiple processors. And we're talking about the actual chip. Okay, the computer only has one CPU chip, and the CPU chip itself only has one computer. Now, the main question is, what kind of association is this? Is this a aggregation, or is this a composition? Okay, now let's just say, for example, in order for the computer processor to live, the computer must live. Okay, remember, composition means that the child class cannot survive without the parent. If we take away the child, which is the computer processor object, the computer itself would not be present. The computer processor cannot live independent from the computer. Okay, but for aggregation, if we were to separate these two objects from each other, then these two objects would be able to live independent from each other. Okay, now again, it's all about perception. It's about how you implement your programs. Some people might say a computer and the computer processor, if you separate them, they cannot live independent from each other. They depend on each other. Okay, so hopefully that clears up some things about this whole association thing. And again, we can go even further. We can create a motherboard class motherboard, and this motherboard class can have a bunch of different properties. Okay, we can have the type of chipset, we can have the max capacity of RAM, all the properties that you can think about on a motherboard. Okay, if you look at your motherboard, look at all of the features it has, look at all of the ports, all of the SATA ports that it has, all these things. Okay, and you can implement that inside this class, and you can create an instance of it, and you can pass it as a parameter into our constructor and assign the motherboard instance to our computer instance itself. Okay, but this is just a very simple example of association. Okay, so hopefully this whole example makes sense. And like I said, just think about objects that are composed of other objects. A computer has a computer processor. A computer processor might have specific properties. It might have specific methods. Okay, a computer has a motherboard. The motherboard itself has a BIOS. Okay, what does the BIOS have? The BIOS might have a settings object that you can use to modify the settings of the BIOS. Okay, animals can have an owner. Owners can have an animal. Students can have a job. Jobs can have a student. So think about all of these objects, these real world scenarios as objects, and try your best to create your own classes, derive those classes, and create instances of it, and then aggregate objects with each other. Okay, so hopefully that clears up what association, aggregation, and composition is. And I highly urge you guys to practice this on your own, because the only way you're going to really fully understand these concepts if you practice. So I'll see you guys in the next episode. Peace.